One of the most important scientific controversies of our time involves the events at the end of the Great Ice Age. More specifically, a remarkable period of time called the Younger Dryas, a period of extreme spasmodic climate swings, the annihilation of megafaunal species worldwide, the sudden disappearance of the North American Clovis culture, major disruptions to human settlement patterns around the globe, all preceded by giant floods and rapid sea level rise. These are the pieces of a puzzle that doesn't fit into the standard model, unless there is a trigger mechanism. What caused all these notable changes in the homeostasis of our global system? In those orthodox models, these data points have no common cause or unifying connection. The fact that they are all happening more or less simultaneously is seen as simply coincidental. So let's continue discussing the model that unifies these issues with a single causal link. Join me today as we square the circle on the history of the Younger Dryas Impact Hypothesis and dig into the evidence for extraterrestrial impacts into an ancient ice age world. Well, here we are again. I'm Randall Carlson, and we're going to continue this really interesting and important discussion about events that occurred at the end of the last ice age. Events that have probably been the most profound in their effect on the human species and the rise and fall of human civilization since we modern Homo sapiens first began to occupy this planet, something like a couple of 100,000 years ago. And in this discussion and quest, I'm going to be joined once again by my friend and colleague, John Arthur. So if there he is.
Howdy, howdy.
In the wings, also our producer, fact checker, co-researcher. I'm sure we could come up with some other labels for him, but I don't know if we would want to express that in polite company, so we'll not do that here. But in any case, hello, John.
Best. Howdy, Randall.
Howdy. So the Younger Dryas, when did you first, can you recall in your life when you first became aware of the Younger Dryas?
Well, so I really come from a evangelical background. And so all of this body of evidence is something that, those who are in young earth creation science, those who follow that hypothesis, there's a lot of shared evidence that we all are looking at, and something doesn't fit the model. But in the last few years, I've become more and more familiar with the Younger Dryas Impact Hypothesis. And it's only been in the last 2 to 3 years. So it's picking up a lot of traction, and it's a very interesting model, one that's much better than the status quo.
Oh, absolutely. I definitely agree on that. I would have to say I first became aware of it probably a little bit before you. I'm guessing probably the late 1980s.
When you say before you really do mean before you, John Arthur. I'm a 94, baby.
Oh, so you weren't even in the world. My God, It's hard for me to conceive of, but it's the 94. So yeah, I'm thinking the late 80s, the early 90s. I could easily look here and see just in my presentation that I think we looked at the last couple of episodes. We were certainly a decade or two in front of the famous 2007 paper by Richard Firestone, James Kennett, Alan West, and others. So anyways, we're kind of moving on. It wouldn't hurt to refer back to that paper because they really did lay out the argument. And that was mostly the focus of the attacks on the part of those who were committed to discrediting the idea. They did not want to open the doors to something from outer space, basically. They didn't want that. Well, we've learned a lot since 2007, and there's been a bunch of new studies that have extended the geographic range of this phenomena probably to at least half the world, half the globe now, maybe more than that. Within the, let's see, with this recent discovery in Siberia, we may have pushed it even further east than it had been. Discoveries in Europe. I think there's now even a discovery from a few years ago in Antarctica, which we'll look at as well, and to see if that is substantial enough to accept it as a proxy for a Younger Dryas event. But if it turned out to be the case that we have YD boundary proxies in the Antarctica, well, we're clearly dealing with a global event at that point, I would have to think. So we have a few papers that I think are very interesting and important in the history of the studies of the Younger Dryas. We're going to look at, over the next couple of episodes where we're unpacking all of this research on the Younger Dryas, we're going to look at a lot of what the critics have said as well. Because you need to look at both sides of a controversy or an argument. Now, I've done that, and I've done that quite extensively, and I want to share that with people because there have been legitimate questions raised by the critics. Don't doubt that for a second. I think, however, though, the proponents of the ET hypothesis have done an admirable job of addressing those questions and criticisms posed by the skeptics of the whole idea. And I think we could also show that the initial response of the skeptics or the critics in a lot of senses was not really fair. It was more, there was a lot more of what we don't like in pure science, because there were ad hominem attacks. There were straw men that were meticulously constructed and then torn apart. There were red herrings galore, bringing in things that weren't really relevant to the question at hand. I'll give you an example. One of the main red herrings is, and of course, ultimately, it's something you would want to factor in to the totality of your understanding, and that is a crater, an impact site, right? That has been one of the ongoing criticisms. Well, in some ways, it has echoes of the critics of J. Harlan Brett's back in the 20s and 30s. Well, if you can't come up with an explanation for these gigantic floods that you're talking about, well, sorry, we can't buy it. Your floods, if you can't explain those floods, invoke and describe some kind of cause, well, they didn't happen. That was basically the attitude. Well, here it's kind of similar. Well, you've got the proxy evidence, right? You've got nanodiamonds, you've got microspherules, you've got the platinum group metals, you've got melt glass, you've got a lot of this stuff, and we're going to be exploring some of that in this episode, right? Well, okay, we need an explanation for that. Now, one explanation that seems to fit the evidence more effectively than any other alternative explanations is some type of a cosmic impact. And I say some type because there are anomalies about the evidence that need to be explained, that don't fit a simplified model of some kind of a homogeneous object, single object randomly hitting the Earth. It is definitely not consistent with that scenario, right? And that is one of the things that the critics were resorting to, is essentially invoking this model of a single homogeneous object randomly striking the Earth, right? And because that model was found wanting, then the whole body of evidence that was being amassed by independent teams was being dismissed. Okay, so let's see. We're going to go up to one of the famous sites called Murray Springs. Let's take a look there at Murray Springs and see where that is on the map. We're taking a little bit of a detour here to tell a story that I think is going to be valuable. I was coming down the stairs, and I think somebody just ahead of me had spilled a little bit. My foot hit it, slid out from under me, and I tumbled down 3 or 4 stairs to the bottom. I sure banged up my left knee. It was painful, but I was very relieved to remember that I happened to pack my CBD from the gods salve. And I was really grateful that I had remembered to do that. So that night I put some of the salve on, went to bed. Though I've, being in the construction and building industry, I've had many falls and injuries and stuff, and I figured I'm going to be laid up with this for a month. We drove home. I think it was 3 to 4 days later. I continued applying the salve, and I would say within a week, I was getting around pretty good. I always bring the oil when I travel, and I'm now, after this episode, I'm like, okay, I'm always going to have the salve with me too. This is from this is our Wikipedia. So we've got Murray Springs is located in southern Arizona near the San Pedro River, and once served as a Clovis hunting camp approximately 11,000 years before present. The site is unique for the massive quantity of large megafauna processing and extensive tool making. Archaeologists identified 5 buried animal kills and processing locations and a Clovis camp location. C. Vance Hayes, who we've already quoted in a previous episode, in 1966, along with Peter Maringer of the University of Arizona, discovered the site while extending the mapping of the area of the Laner Mammoth Kill site 19 kilometers to the south. Yeah, we visited that one as well. The archaeologists located 2 concentrations of mammoth bones that day. They were convinced the area was a Clovis site based on the bones, and because Murray Springs shared the same geological characteristics as the Laner site. Funding by the National Science Foundation and the National Geographic Society enabled excavations from 1967 to 1971. Some of the significant artifacts found during the excavation included hearths, a bone tool, projectile points, lithic tools, and debitage. The bone tool is believed to be a shaft straightener. So anyways, that's the site. The 5 buried animal kills and processing locations contain bones of mammoth, bison, horses, camels, canids, probably dire wolves, I'm guessing, and rodents. A worker found a single pot shard on the surface of the site that was associated to use approximately 1300 to 1450 of the Common Era. So that was of no relevance. That was a later thing that ended up there. Archaeologists noted peoples have used the spring over an extended period. An analysis of the site is interpreted as leaning against the extraterrestrial impact theory of the Pleistocene extinction. Now, there we go. See, okay, so we're going along. Everything is cool, factual. Then we get to this, because it says an analysis of the site is interpreted as leaning against the extraterrestrial impact theory of the Pleistocene extinction. So there we there we go, and they quote one paper which we're going to look at when it comes time to examine the efforts of the critics to dismiss this idea. This is going back to C. Vance Haynes and others. It's entitled "The Murray Springs Clovis Site, Pleistocene Extinction and the Question of Extraterrestrial Impact." And that was in 2010. Maybe as a response to this, because I have it right here. I have quotes from it, and this is interesting. Okay, so here's the Murray Spring Clovis site, Pleistocene extinction, etc. And what did they find there? It says the Clovis occupation surface at Murray Springs is a sharp stratigraphic contact upon which rests black organic clay, the black mat. Okay, I've been there, seen it. It's very prominent. very distinct. You can see it. But then it says it is believed to result from an algal bloom. Algae, a bloom of algae. But of course, that implies that the ground surface is saturated wet. The Murray Springs black mat covers and preserves the Clovis Age landscape. Hundreds of Clovis stone artifacts in direct association, this is key, in direct association with skeletons of 2 mammoths, 11 bison, and bones of a dire wolf. Yeah, okay, so yeah, a dire wolf and horse were exposed under the black mat by archaeological excavations. And that is significant because they're not, notice they're not mentioning that they're finding them above the black mat, only below. Well, then they found, they found this from the same paper. They found, let's see, they were using, among the buried samples, they took samples, and they analyzed those samples, and the magnetic particles, 0.82% of the total separated from each fraction. Magnetic particles are most concentrated in the silt to fine sand fractions. Examination under 100 scale and 400 scale in both reflected and transmitted light reveal what appear to be subangular detrital magnetite grains and rock-forming silicates, quartzes and feldspar, with a few silvery microspherules, ranging in size from approximately 10 to 70 microns. They look like microscopic, highly polished ball bearings. And here, these like highly polished ball bearings. Are you seeing these? This is our photomicrographs of magnetic microspherules.
Yes, sir.
So now, notice they are finding these magnetic microspherules. And what is the source of those? Let's go to the next slide here. We already read this, but then they go ahead and they say this: we retain the opinion that we have yet to understand what happened approximately 12,900 calendar years ago that abruptly terminated the major elements of Pleistocene megafauna. The ET impact hypothesis has sparked several investigations that are leading to new knowledge. And although our data from Murray Springs and elsewhere do not support it, neither do they preclude it. Oh, well, now that's, I would say, is pretty fair-minded, right? Wouldn't you agree?
It's almost like it doesn't necessarily lean against the Younger Dryas hypothesis.
Well, yeah. So if we go back to what they're saying here, an analysis of the site is interpreted as leaning against the extraterrestrial impact theory of the Pleistocene extinction. Now, is that your takeaway from, he's quoting whoever wrote this for Wikipedia, it's quoting the article we just read from. Now, did you draw the conclusion that they were leaning against? It said, no, it doesn't prove it, but neither do they preclude it. They also said, the ET impact hypothesis has sparked several investigations that are leading to new knowledge. They're acknowledging that. And although our data from although that's an important qualifier word, although our data from Murray Springs and elsewhere do not support it, neither do they preclude it. Okay, I read that, and then I read this final sentence here in this description from Wikipedia. An analysis of the site is interpreted as leaning against the extraterrestrial impact theory of the place. Now, if you read this, you would think, oh, okay, well, but see, then notice here that nowhere in this article, the Murray Springs Clovis site that's on Wikipedia, do they even mention the magnetic microspherules. It's not even mentioned here. So, I mean,
and they certainly don't provide another mechanism for those proxies. They provide zero mechanism And they
Right.
don't mention them.
And as we go through and work through this material, we will learn that magnetic microspherules are one of the consistent accepted proxies found in associate. Maybe if you isolated it and you said, okay, there could be an alternate explanation origin for these magnetic microspherules. But if you find them in association with nanodiamonds or shocked quartz or melt glass or platinum group metals or any of the other things, well, yeah, then it's a pretty good bet that those magnetic microspherules are the result of of a cosmic impact of some kind. I'm going to pause for just a minute to talk about our partners over at Shippo, who may save you a significant amount of headache in your day-to-day business. We sell a variety of geometry tools and models, like our beautiful platonic solids here at Randall Carlson LLC. And when it comes to managing shipping, e-commerce, and returns, we've been using Shippo for over 4 years now, and we're very pleased with their service. Shippo's interface is intuitive, the primary order page is easy to navigate, and we have enjoyed stellar technical support. If Shippo can help you with your needs, please use the code below to partner with a great company while supporting our work here at Squaring the Circle. Thanks, and now back to the show. So that's the Murray Springs site. And then we had this, the work of a team out of, let's see, they are, we found Melissa Scruggs. She is with the Department of Geosciences at the University of Minnesota. And her and how many colleagues did an excavation in the Baja Peninsula of California. And they begin this, and they report, this was at the North Central Section 44th Annual and Southern Central Section Joint Meeting of the Geological Society of America. And this was a presentation, paper number 1, presented, and this meeting was occurred over April 11th to the 13th back in 2010, same year now as this Murray Springs Clovis site we just were quoting from. And the title of this paper is Investigation of Sediment Containing Evidence of the Younger Dryas Boundary Impact Event El Carrizal, Baja California Sur, Mexico. So I think you just had a map up there. We can see where this, yeah, zoom out a bit. Yeah, there we go. Way down there in the bottom end of the Baja Peninsula is where this site is that was examined by this team. And just, is it right there? You got it right. So must right there, interestingly, in that little triangle. And okay, and then we have what is that? A Catholic church right there, I believe.
Mm-hmm.
Huh. Okay.
I would assume it would be somewhere out here in that outcrop.
Yeah, you're probably right. Yep. So, the Younger Dryas Boundary Extraterrestrial Impact Hypothesis posits that one or more, important because I'm convinced it was more than one, but in 2010, that's an open question. I think the evidence comes down pretty solidly on the favor of it being a multi-impact event. But in 2010, in the early stages of really discussing this seriously and scientifically, one was considered, because of course that was the standard model of virtually all impact events, right? One or more extraterrestrial impacts exploded over the Laurentide ice sheet, 12,900 plus or minus 100 years ago. The event is purported to have triggered the Younger Dryas stadial and coincides with the Rancho La Brea termination and the disappearance of the Paleo-Indian Clovis culture. So let's back up. What do we mean by a stadial? What do we mean by that? The Younger Dryas stadial. Okay, very briefly, I've explained this before, but it never hurts to reiterate a little bit. Okay, you've got, let's go, so you got full glacial, interglacial. Full glacial, 15 to 20,000 years ago, 6 million cubic miles of ice, temperatures 10 degrees colder worldwide, et cetera, et cetera. Interglacial, like right now, okay? Now, think of those as two extremes. And we can see in the record of climate change that the climate has oscillated between glacial and interglacial with wide swings. But there's also probably even more lesser swings where it doesn't go to full interglacial or back to full glacial. Where it swings to the cold but doesn't go to the full glacial, we're referring to that as a stadial. So you've got a stadial and you've got an interstadial. You've got a glacial and you've got an interglacial. And so you could almost think of the oscillation like this: stadial, interstade, glacial, interglacial. Stadial, interstade, glacial, interglacial. So it's really more, I guess you could think of it as a magnitude function. Okay, so that's the Younger Dryas stadial, because what happened? It shifted back for 1,300 years to glacial, almost glacial cold, maybe glacial cold, in which case maybe stadial wouldn't be the appropriate term. But again, hey, this is 2010, okay? What'd they know back then? Okay, it also coincides with the Rancho La Brea termination, the La Brea tar pits out in LA, where all of the extinct megafauna are trapped in the tar. That gave its name to this particular epoch or stage of mammalian life on Earth, or in North America, the Rancho La Brea. So they call the Rancho La Brea termination essentially means the extinction of the megafauna in North America, okay? And the disappearance of the Paleo-Indian Clovis culture. Evidence supporting or refuting this hypothesis has great implications for the fields of geology, paleontology, and archaeology. And here's some of the geochemical markers of the YDB, Younger Dryas Boundary impact. We include magnetic and carbonaceous spheroids. Okay, so just like they found at the Murray Springs, they found magnetic spheroids. Okay, elevated levels of radioactivity and iridium, and nanodiamonds, and a special type of nanodiamond called Lonsdaleite, which we should learn more about that so we can distinguish between nanodiamonds and Lonsdaleite. And Lonsdaleite, if I recall, are cubical structures. Let's see what it says. It's named after, what's her name? She was a really highly accomplished woman scientist. Lonsdale, I believe. This paper by Scruggs goes on, says the event horizon at sites across North America is often overlain by a darker layer, the black mat. Our field site for testing the Younger Dryas Boundary ET Impact Hypothesis is located on the El Carrizal Fault. And you found that. We couldn't see the fault, but maybe the fault is represented there by that outcrop. I'm not sure. South of La Paz in Baja, California. The site is situated along the uplifted or southwest side of the fault within an arroyo, exposing Pleistocene, Holocene transition sediments. The presence of in situ Rancho La Brea megafauna fossils at El Carrizal was independently verified by investigators from the Universidad Autónoma de Baja California Sur in La Paz. Cranial and postcranial sections of Mammuthus columbi, which is the Columbian mammoth, were excavated from the sampling site in 1997. Sediment samples were taken from a 3-meter stratigraphic section, so about 10 feet, at El Carrizal, which spanned the sediments where the mammoth fossils were located. The section included an anomalous greenish clastic layer. What do I mean by clastic? Basically broken rock, okay? or rock that is contained. Think of it as chunks like raisins in bread pudding. And the raisins are the clasts, and the pudding would be the matrix. Okay. So there's a greenish clastic layer at approximately 138 plus or minus 6 centimeters below the road surface. This layer suggests a correlation to the black matte stratum noted at many other terminal sites. Now, here's the important part. Preliminary and laboratory analysis yielded magnetic spherical particles under the 60 to 70 power magnification. And a peak in radioactivity was found at a depth of 136 to 138 centimeters, coinciding with the lower part of the darker green layer. Elemental analysis for iridium and Lonsdaleite are currently underway. So did you find Lonsdaleite?
So Lonsdaleite is a hexagonal structure, unlike the typical nanodiamond, which is a cubic structure.
Cubical structure.
Lonsdaleite is named after Kathleen Lonsdale, and
she was, what was she, a geochemist?
Yes. So
you got a little bio there on your, don't
I
you?
do. Let me go ahead and pull it up. This is courtesy of Wiki. So here's the lady herself. And so, yes, she is a crystallographer.
Okay.
Yeah. Pacifist and prison reform activist. This woman was busy.
Wow. She proved in 1929 that the benzene ring is flat by using X-ray diffraction methods to elucidate the structure of hexamethylbenzene.
Gesundheit.
She was the first to use Fourier spectral methods, which, while solving the structure of hexachlorobenzene in 1931. So she was, fellow of the Royal, one of the first two women elected a fellow of the Royal Society. So she was no lightweight. First female professor at University College London, first woman president of the International Union of Crystallography. I wonder what she would think if she knew that her work is being used to support the extraterrestrial impact hypothesis. So she died in 1971. Wonder if Lonsdaleite was even being used then as a proxy. Or where did Lonsdaleite first show up? In a laboratory or in nuclear testing? Or was found in meteorites? I know it was found in meteorites. And I believe it was produced as a byproduct of nuclear weapons testing. Now, I'm not sure of that, but and there are probably productions of it in a laboratory, I'm guessing.
Yeah, Canyon Diablo is the Canyon Diablo iron meteorite fragment is the first formation, I believe, that I can find at the moment that has Lonsdaleite.
Okay, and so, I believe that makes sense because this is actually, that's what's also known as Meteor Crater near Winslow, Arizona.
1891, so they would have found it at that time.
Okay, so interesting. Okay, there's more of a story here that I don't want to get into in too much detail now, but that would be good to know. So, Meteor Crater, that we've, been 3-4 tours, I think, there now. I've taken groups to there because it's such an impressive big hole in the ground. But, okay, so we can add another interesting detail to the studies of this, that was the first place that Lonsdaleite, but when it was probably not called Lonsdaleite when it was found in those meteorites, in the meteor fragments.
Well, Kathleen Lonsdale was born in 1907 or 1903. Let me pull that up. Kathleen Lonsdale was born in 1903, so it couldn't have been called Lonsdaleite at the time.
No, nope. Okay, well, there's an interesting story there. She sounds like a rather interesting woman, and again, no lightweight. And I could make some quasi-political comments about, I'll bet, I have a feeling that she probably very rarely complained about discrimination. She was probably too busy with her research and her studies and her work and her extracurricular activities to even think about that, I'm guessing. All right, so Lonsdaleite then is one of the proxies that we would list in that list of proxies that would include nanodiamonds and magnetic microspherules of different kinds, magnetic grains, melt glass, iridium, platinum, osmium, etc. So now we're going to move that same year, 2010, interesting year for impact studies, Younger Dryas Impact Studies. This is William C. Mahaney, David Crinsley, and Vale Calm. I don't know. Let's see, we can see who the affiliations are here. This was published in the journal Sedimentary Geology, 2010. The title of this paper by William C. Mahaney, who is with Quaternary Surveys out of Canada, David Crinsley with the Department of Geological Sciences, University of Oregon, and Vale Calm, Institute of Ecology and Earth Sciences, Tartu University in Estonia. Okay, didn't know anything about, and don't know anything about Tartu University in Estonia. But anyways, so you had, international trio here. And here's the title of the paper: Evidence for a Cosmogenic Origin of Fired Glaciofluvial Beds. Fired Glaciofluvial Beds. Interesting. So we've learned this term, glaciofluvial, when you have the effects of glaciers and the effects of flowing water combined, we use the term glaciofluvial. So here we have fired glaciofluvial beds in northwestern Andes. Correlation with experimentally heated quartz and feldspar. So let's see what this study was all about. So in the Andes, okay, so here we go. This is from the abstract. Fired sediment considered equivalent to the black mat impact of 12.9 thousand years ago has been located and analyzed in the Andes of northwestern Venezuela. The black mat refers to possible fallout from the Encke comet airburst presumed to have occurred over the Laurentide ice sheet. We should pause there. The Encke comet, the fact that he mentions that is interesting. That is an hypothesis. We don't have proof, but it fits the bill pretty good. Now, Encke's comet, what do we know about Encke's comet? Is it associated with a meteor stream?
Mm-hmm.
Yes, it is. Do you know, John, which one?
I know you're going to tell me, Randall.
I was going to let you have one guess.
One guess? It's not the Torrid, is it?
Yes, it is.
Well, that narrows it down pretty good.
It does. I knew you would get the answer right. That's why I went ahead and put you on the spot.
It's the relevant one.
Yeah. Comet Encke is associated. It's part of the Torrid family of meteors and asteroids and pseudo-cometary objects swirling about the sun out there. And Encke, I think, is 3.3 years, one full elliptical cycle.
Sounds right. I had to look it up because I was captioning one of the videos. So how do you spell Encke? So I had to look that up.
Encke.
Eke. Yes, I had to look that up.
And that's different than the god Enki from Sumerian mythology. Just let's be clear on that, okay? Enki is not named after the Sumerian god, named after the astronomer that discovered it. Okay, So this though, okay. So the Anki comet airburst. Now we're going to definitely come back to that. Why the Taurid meteor stream seems to be a prime candidate, and I think the evidence is lining up pretty convincingly that the Taurid meteor stream is a prime candidate for the progenitor of the Younger Dryas whole series of events. So, presumed to have occurred over the Laurentide ice sheet. The impact spreading ejecta over large portions of North America and Europe, making it an interhemispheric event of considerable magnitude. These possible equivalent beds in the northern Andes, first considered to result from a lightning-induced conflagration adjacent to the retreating late Wisconsin or Merida glaciation ice, are now known to have undergone intense heating upon impact to a temperature much higher than what would occur in a wet first stage successional tundra. I'm going to back up for a minute, toot my own horn. Presumed to have occurred over the Laurentide ice sheet. This was a scenario that I began to ponder at least by 1990. I was pondering that. And I have recorded, only audio record, but I have an audio recording of 5 lectures that I gave at Warren Wilson College in North Carolina in 1995 or 96. And I'm describing a multi-impact event over the Laurentide ice sheet. I do not reference the Younger Dryas, although I give the date of there being something exceptional happening around 12,900 years ago. We should get a transcript of that because I kind of lay it out. And it's so very gratifying to me to see the rest of these guys catching up. Okay, so then, so they did look up FESEM, which would be a type of scanning electron microscope.
A field emission scanning electron microscope.
Mm-hmm. So field emissions, does it give us a little?
Okay, it's an advanced type of scanning electron microscope, or SEM, that utilizes a field emission electron source to produce a focused beam of electrons. This allows for high-resolution imaging of surface structures and features of materials. The FESM is known for its ability to achieve a higher magnification and resolution compared to traditional SEMs, making it a valuable tool for research and analysis in various fields.
So field
emission
electron microscope. So they used Mahaney and his 2 colleagues did their analysis using both standard scanning electron microscopy and field emission scanning electron microscopy. And what they showed was massive disruption, massive micro disruption on grain surfaces, fractures diminishing with depth toward grain interiors, and carbon welded onto quartz and plagioclase minerals. The presence of copious monazite in the carbonaceous coatings is considered part of the incoming ejecta. Monazite, M-O-N-A-Z-I-T-E. It's considered monazite in the carbonaceous coatings is considered part of the incoming ejecta. So you've got carbon welded onto quartz, and then because of the presence of this copious monazite in the carbonaceous coatings, it's considered part of the incoming ejecta, as it is not a common indicator mineral in the local lithology. So what did you find for monazite?
So monazite is a phosphate mineral that serves as a significant source of rare earth elements and thorium. It's known for its reddish-brown color and occurs as small grains in various rocks or as monazite sand in placer deposits. Monazite is commercially available for its rare earth element content.
Okay, so what they're saying here, there was no monazite minerals in the local lithology, in the local rocks, those kind of rocks. But there was copious monazite in these carbon material that's welded onto the quartz.
So it's foreign, you could say, not terrestrial.
Most likely not, right? Well, it goes on to say here, oh wow, the intergrowth of carbonaceous black matte material with thermally disrupted and fragmented quartz and feldspar. And feldspar is what I think the most abundant mineral on Earth, isn't it? Next to quartz, perhaps. So you have the intergrowth of carbonaceous black matte material with thermally disrupted and fragmented quartz and feldspar.
Yeah, feldspar is 60% of the Earth's crust.
There we go. Okay. So disrupted, fragmented, thermally disrupted from heat, and fragmented quartz and feldspar. Okay. So you've got the intergrowth of carbonaceous black matte material with thermally disrupted and fragmented quartz and feldspar, a welded patina of 100 to 400 nanometer thickness could only occur with temperatures in excess of 900 degrees centigrade. The event interpreted here to be of cosmogenic origin. So this welded patina, 100 to 400 nanometers in thickness, there could only occur with temperatures in excess of 900 degrees centigrade. Convert that to Fahrenheit, if you don't mind.
So that would be 1,652 in freedom units Fahrenheit.
Okay, so that would hurt if you got burned by that.
1652. Had to be at least 900. Could have been hotter.
Okay, I got a picture of monazite. So it's a rare phosphate mineral with a chemical composition of, we don't need to get into all of that. We've got lanthanum, neodymium, thorium, but it usually occurs in small isolated grains as an accessory mineral in igneous and metamorphic rocks, such as granite, pegmatite, schist, and gneiss. Monazite is an important ore for thorium, lanthanum, and cerium. It is often found in placer deposits. Like you said, India, Madagascar, and South Africa have large deposits of monazite sand. Could that possibly? Now, I know South Africa has had some major, huge impacts in several of them down there. I wonder if the large deposits of monazite could be associated with that. Monazite is radioactive, sometimes highly radioactive, and specimens are often metamict. Okay, well, that's a picture of a monazite crystal. Okay, let's go on here. Same paper. The reversal of global warming during the Alarode subchron and the sudden onset of the Younger Dryas cooling event has been documented by a number of researchers. Coinciding with a large-scale Clovis age megafaunal extinction, it had far-reaching consequences affecting the geoecological environment across North America and Europe. Newly discovered sites in Europe indicate the event was indeed interhemispheric and may have affected the entire world. And I think what we've learned in the 15 years since then is we can say with almost certainty that it did in fact affect the entire world. Although clearly contentious as to proof for an extraterrestrial origin of the black mat, the one site location in the northern Andes described herein and new evidence from Patagonia point tentatively to either an asteroid or comet event that reached far into South America, perhaps even to the Antarctic. And what we have here is your thick carbon coat on an unidentified disrupted silicate showing heavily fractured surface. It looks like it's been broken along these angles here. Thick carbon coat. I guess that's what this smooth part is right here, is the thick carbon coating on an unidentified disrupted silicate showing heavily fractured surface. And here's your energy dispersive spectrum, energy dispersive spectroscopy spectrum, which if you look up EDS for us, look up energy dispersive spectroscopy.
EDS is an analytical technique used to determine the elemental composition of a sample. It works by detecting and analyzing X-rays emitted from a material when it's bombarded with electrons, usually in a scanning electron microscope. The energy of these X-rays is unique to each element, allowing for identification and quantification of the elements present.
Okay, well, that's what we've got right here. We've got an EDS, energy dispersive spectroscopy spectrum right here as an example. And what we have here is this is your kilovolts, which is the charge of these the charges coming off when you bombard the sample, and you're getting the spectrum. You're analyzing the spectrum, which is going to contain peaks that are associated with the frequency of those particular elements. So you can see here, you got the biggest spike, interestingly, is gold. You got a big spike of carbon there, so that's what we were reading about, the carbon. We've got some oxygen. We've got aluminum, silicon, chlorine, calcium, manganese, and iron. So this shows aluminum, silica at 1:5:1 in that ratio, 1.5 to 1. Probably calcium plagioclase with cosmic aluminum. The high carbon is from impact ejecta and ignited terrestrial vegetation. Interesting. So that's where the carbon came from. Impact ejecta. So when that impact slams into the earth, the ejecta explodes outward, and then it creates secondary fires. That material is now igniting the vegetation, the terrestrial vegetation. So that's what you see here. The high carbon is from impact ejecta and ignited terrestrial vegetation. Traces of manganese and iron are typical components of the black mat. Origin of chlorine is unknown, but might originate from a comet/meteorite airburst. I wonder if chlorine was found in association with Tunguska. So the database described herein does not conclusively prove an ET impact airburst at 12.9 for the black mat, as we have detected no irrefutable PDFs. That's planar deformation features, which is a feature that occurs in quartz when it's subject to shock pressures. It forms a network of fracture lines that are very conspicuous when you look at them through a microscope. If you look up shocked quartz, okay, for the black matter, we have detected no irrefutable PDFs, shock melted quartz, iridium, or nanodiamonds in the samples analyzed thus far. But the data described here highlight a mat of glassy carbon spherules fused and welded onto alluvium, firmly dated to within the Younger Dryas initiation window. So clearly something happened. The carbon-rich mat, a nanometer thick coating, is encrusted on brecciated or broken fractured minerals of quartz and feldspar. The disrupted mineral surface is interpreted to result from mass impact and extreme heat. In 8 out of 10 occurrences, carbon is coated or welded onto mineral grains. So, I mean, clearly they're finding something. He says it doesn't prove an ET impact, but it certainly is indicative that something happened involving pressures and high temperatures and so on. So what did you find for shocked quartz? Ah, look at that. Very distinct. Yeah.
And it forms a pattern.
Whitman-Stanton, I think it's Whitman-Stanton pattern, but yeah, very distinct. Is there any more examples?
Let's see here. I thought I had one more from this page.
So that was shocked quartz found in association with the KT boundary?
With Chicxulub, actually.
Chicxulub, yeah, that's the KT boundary impact.
Yep.
Interesting. Yep. Okay.
I've got you another one right
So shocked quartz is considered to be one of the major diagnostics for high pressure impact events. Yeah, there you can see that same kind of a pattern again.
Got two for you there.
Yeah, shocked quartz, photomicrograph of shocked quartz grains, 0.13 millimeter across. That's from the Chesapeake Bay impact crater. Okay, so the Chesapeake Bay impact crater is worth talking about because it was associated. It seemed to happen very close in time to an impact of roughly the same size up in Siberia called the Papagai. And there seems to have been a mortality event associated with it. And there was also tektite formation over the southeastern United States from the Chesapeake Bay impact. And there is a display, or they used to have a display of Georgiites or Georgia tektites. Georgiites is what they were called, but they have been found in Georgia down just below Macon. On the fall line where the transition occurs from the Piedmont to the coastal plain. And there's an outcrop there of a late Eocene sand deposit that would have been the surface of the ground when that impact occurred in the Chesapeake Bay, roughly 35 million years. That rained down. Now, it's now buried under dozens of feet of accumulated sediment since then, but at that horizon, if you go down there, like particularly after a heavy rainstorm, sometimes you can find tektites washed out of the embankment there, right where that Eocene, Oligocene strata is exposed. So like it says, this doesn't prove it, but it's certainly consistent with it. If this evidence is not from an impact, then what's it from? Once again, is it just a coincidence? Well, let's see here. If we go, let's see, to the Journal of Glaciology. Let's see, what's the date on this one? Again, 2010, big year. So this is the paper Discovery of a nanodiamond-rich layer in the Greenland Ice Sheet. Let's see. So this is in the Journal of Glaciology. And, I think some of these are probably available on Google Scholar. A lot of them are going to be behind paywalls, but we can look and see if listeners want to actually download some of the original papers that we're discussing here and read them yourselves, I would highly, highly recommend that. And don't be too, if you don't have the geological training to understand all the lingo, hey, it's all right there. Just sit down at your computer, read the paper, and when you come up with a term you don't know, look it up. And John is looking, let's see, the one we just looked at was evidence for a cosmogenic origin of fired glaciofluvial beds. Probably just evidence for a cosmogenic origin of fired. And if it is available on Google Scholar, it should say, give you an option for downloading a PDF.
The Greenland Ice Sheet is available via Cambridge.
Okay. Is that the paper by William Mahaney?
Let's see. September 2017 is what I'm looking at.
Okay, that would not be the one we were.
It's not the same one that you just looked at. It's using the same graphics.
Okay.
So I've got William Mahaney for evidence of a cosmogenic origin of fired glaciofluvial beds in northwestern Andes. So that one's available via ScienceDirect.com.
Okay, well, guess what? You can get it directly also from Cosmic Tusk.
Nice.
So there's a PDF link. I just put in, I got as far as evidence for a cosmogenic origin of fired, and that was all I needed to put in. I clicked, and what came up was a link to the 2010 Sedimentary Geology, and there, our friend George Howard has been kind enough to put it up there and make it available to people. You can go on there and click it. It's also available in PDF form from academia.edu. So it is available. You can get, it's not behind a paywall. If you want to go in and download it and read it yourself. So the next one here, this discovery of a nanodiamond rich layer. I'm going to look that up right now. And a lot of these.
So Andrei Kurbatov?
Kurbatov, yeah.
So I have that on psu.edu for Penn State.
Oh, okay. Yeah, discovery of a nanodiamond rich layer. There it is. Yeah, there's several. Yeah, there it is. PDU, UMaine, PDF, UMaine, like the state, .edu. So it's there. PDF, escholarship.org. So it's there. So again, people, if you're listening, you can download a lot of these papers. So let's see here. Let's see what this one says about discovery of a nanodiamond-rich layer in the Greenland Ice Sheet. We report the discovery in the Greenland Ice Sheet of a discrete layer of free nanodiamonds in very high abundances, implying most likely either an unprecedented influx of extraterrestrial material or a cosmic impact event that occurred after the last glacial episode. From that layer, we extracted endiamonds and hexagonal diamonds, Lonsdaleite. So they got both of them. They found them in the Greenland Ice Sheet. An accepted ET impact indicator at abundances up to about 5 million times background level. 5 times 10 to the 6th, 5 million times background levels in adjacent, younger, and older ice. The nanodiamonds in the concentrated layer are rounded, suggesting they most likely formed during a cosmic impact, though some process similar to carbon vapor deposition or high explosive detonation. Well, carbon vapor deposition is just when you have temperatures high enough that it's vaporized carbon, and then that cools, crystallizes out and deposits, and so, or high explosive detonation. So clearly something. something here going on. This morphology has not been reported previously in cosmic material, but has been observed in terrestrial impact material. Okay, so what he's saying there is that cosmic material that's constantly microscopically raining down on Earth. It's an ongoing uniformitarian gradualistic process, right? But he's saying that this morphology has not been reported previously in that kind of cosmic material, but has been observed in terrestrial impact material. This is the first highly enriched, discrete layer of nanodiamonds observed in glacial ice anywhere, and its presence indicates that ice caps are important archives of ET events of varying magnitudes. Using a preliminary ice chronology based on oxygen isotopes and dust stratigraphy, the nanodiamond-rich layer appears to be coeval with nanodiamond abundance peaks reported at numerous North American sites in a sedimentary layer, the Younger Dryas boundary layer, dating to 12.9 plus or minus 0.1 thousand years ago. However, more investigation is needed to confirm this association. Of course, once again now, so we just had the Mahaney group in the Andes. This same year, they're finding these microspherules and evidence of high temperature phenomena, right? Now here in Greenland, we've got this team, and this is quite a team. If I go back here, I mean, this is a lot of guys here, a lot of people. I shouldn't say guys. There's Sharon B. Sneed, so we got some ladies in there, but a lot of these guys I'm familiar with. Alan West. There's Douglas Kennett and James Kennett, son and father. Ted Bunch, who regrettably one of the leading lights in analysis of geocosmic materials, died. I think it was last year. Who other name do I recognize? Whitkey. Yeah, we've read papers by him. Thomas Stafford. We almost got him to take us out to a look at a cave in Texas that we're, but he's quite old now, and I don't think he was up for it. Who else? Wendy S. Wolbach. She did a lot of work on firestorms at the KT boundary. Charles R. Kinsey. So there's some Adrienne Stitch. There's some pretty exalted names here within the scientific community that would have the wherewithal and the expertise to determine if these are in fact impact phenomena or not. And what they're showing here, this is interesting because this applies not only to this paper, but Dye 3, that was where one of the early core extractions took place. But as you can see that it's very near the edge of the ice sheet. And same with Camp Century up here. So with this one here, they were all near the edge of the ice sheet. Well, the problem there was the ice is a lot more dynamic near its edge, flowing back and forth, melting episodes, and so on. It's much more unstable near the perimeter of the ice sheet. So what they did in the late 80s, they went to right up here, GISP2 and GRIP, European team and American team, and they took 5 seasons to penetrate fully through the ice sheet to get to bedrock. But the reason they went, this is called the Summit Core expedition, because they went to the Greenland summit, because there the ice is the most stable, and the preservation of the layers is more visible and organized to where. So anyways, let's see here. Let's see. Recently, scientists reported an abundance peak in nanodiamonds at multiple locations across North America that is restricted to a thin sediment layer, the Younger Dryas boundary, which dates onset, as we've seen, 12.9 peak in hexagonal diamonds. Lonsdaleite was also reported at the YDB in Arlington Canyon, California. The only known explanation for terrestrial Lonsdaleite is by arrival inside extraterrestrial objects and or by impact of such objects with the Earth's surface. This discovery begged a prediction that a coeval layer with high nanodiamond concentrations should be preserved in the Greenland ice sheet. No layers of nanodiamonds have previously been reported from the Greenland ice sheet or any other form of glacial ice. Consequently, we conducted a pilot investigation on a section of the Greenland ice sheet that potentially spans the last deglacial in search of a layer containing an abundance of free nanodiamonds that might be coeval with that of the Younger Dryas boundary, a study that included both field and laboratory components. Ice samples of large volume were necessary to conduct these investigations, and sufficient ice from deep cores. Greenland Ice Sheet Project 2, Greenland Ice Core Project, and North Grip are unavailable. Consequently, we followed the earlier approach of Rhea and others in 2002 and Petrenko and others in 2006, who sampled the ice margin to obtain a stratigraphic sequence over the interval from the last deglacial through the Holocene. Let me see, I think we can, yeah, here we go. So here you've got the dust layer. And so below you've got this dust layer is the equivalent of the black mat layer, okay? So basically then this is where that transition took place. So you've got this trench, upper section of the trench at whatever, showing a dusty ice layer.
Can you say that one more time, Randall?
That's probably Icelandic.
I believe it must be.
And I believe it must be. I do not speak fluent Icelandic. I know that's a deficiency in my
Kangerlussuaq is the best thing I can imagine.
Kangerlussuaq, we'll go with that. So it's showing a dusty ice layer sandwiched between clearer ice. The nanodiamond peak layer lies immediately below the base of the dusty layer. You see that right here, the red layer. So there's the nanodiamonds. And then on top of the nanodiamond layer is this layer of ice that had a lot of dust in it while it was being precipitated. Preliminary data suggests that the dusty layer may represent the Younger Dryas cooling episode. If so, then the nanodiamond peak immediately predates the base of the dusty layer, marking the Younger Dryas onset. So, in cooperation with a PBS Nova Documentary Productions, we conducted fieldwork in late 2008, during which several authors sampled at a margin site east of Kangerlussuaq, West Greenland, approximately 1 kilometer inland from the ice margin. Our goal was to collect continuous samples of ice extending from the end of the last glacial episode through the early Holocene, including the 1,300-year-long YD cooling episode. One of the authors, JPS, has considerable experience sampling along the Greenland ice sheet margin, and he identified a candidate for the YD age section based on visual inspection of dust stratigraphy. Our sampling was guided by the presence of clear dust pore ice of assumed early Holocene age, stratigraphically higher than a sharp visual change into dusty ice of inferred Younger Dryas age, beneath which was another sharp change into clear ice of assumed Balling Alarode age that was preceded by dusty ice of assumed late glacial age. So let's go back and look at the picture one more time here. Whoops. So the nanodiamond layer. So if you were to chop, go in from the margin and take core samples, you would then encounter this dusty layer sitting right on top of the layer of nanodiamonds. Oh yeah, look at this. So here's your estimated concentration of nanodiamonds by depth and sample for the Kangerlussuaq section, based on high resolution HREM, high resolution. high resolution, that's microscopy. What is the E again? Let's look that up. I'm going to learn every one of these things by hook or by crook.
HREM. It's hard for me to read that screen typically.
Yeah, HREM.
So that's going to be high resolution episcopic microscopy.
There we go. Episcopic. Say that again.
Episcopic, high resolution episcopic microscopy.
Microscopy. Okay. I think what we should do is, I think we've got, I guess we could probably get somebody like Malcolm LeCompte or Dr. Stephen Collins on here, or even Dallas Abbott, who are very knowledgeable in this, and to help us to really get a good, thorough understanding. Because I have a vague understanding of how all of these technologies work, but I like to get a little bit more deep into things. That's just the way I prefer. So I'd rather have a more working knowledge of all of the various types of technologies being used to enhance our ability to perceive and understand things, both on the microscopic level, but also the macroscopic level. But this is interesting. Look at your depth. This is going down core, right? So look what happens when you get down to sample number 14 at 5.4 meters below the surface. What is that? Million. This is over a billion. 1,414 million nanodiamonds per liter. And then at 5.55 sample 13, there's a lot more than the background. But boy, right here at this layer, so right there at layers 13 and 14, between 5.55 depth and 5.4 depth, you've got basically billions of nanodiamonds. And then look at over here, this graph is an interesting one. Here's your iridium sample number, depth for your meter, and here you can see the spike. And notice, here's your temperature graph. Look what happens right here. Shifting to the left is cold. So you've got this deposition of the nanodiamond layer, then you've got the dusty area, and coinciding, really looks almost exactly precisely, you've got this major shift to the left, which means cold. So this is your Younger Dryas cold right here, the beginning of it. And I'm guessing then this is the 1,300-year period that brings us out of the Younger Dryas here. But this spike in the middle is interesting. So that looks like it would come like about halfway through that Younger Dryas 1,300 years. So
is this the micro pulse that you were talking about 2 or 3 episodes ago?
Probably. The final and preferred hypothesis is that the Greenland nanodiamond peak layer, which appears to date to the onset of the Younger Dryas, is the result of a major impact event. In support of this, the continent-wide Cretaceous Tertiary, or KT, boundary layer is accepted to contain nanodiamonds that did not arrive from space inside the impactor, but rather crystallized from carbon-rich terrestrial material during that hypervelocity impact. During our Greenland research, we also examined nanodiamonds extracted from KT sediments collected in Caravaca, Spain, and Needles Point, New Zealand. The impact layers at both sites display substantial abundances of Lonsdaleite and nanodiamonds having the same morphology and range of sizes as those found in the Greenland samples. Now, that to me was extremely interesting when I read it, because I thought, okay, one of the proxies that helped to confirm the impact scenario at the KT was the finding of this Lonsdaleite and nanodiamonds in abundance. Well, now, come ahead by 66 million years, and you've got the Younger Dryas boundary, and it's almost like coming full circle in a way, because now here at the Younger Dryas boundary, we're finding the closest analog in terms of the Lonsdaleite and nanodiamonds to that famous impact that wiped out the dinosaurs. While background levels were at zero or very low, as they are in Greenland. Likewise, nanodiamonds extracted from Younger Dryas boundary samples collected in North America and Europe display the same rounded morphology and range of sizes as those found in the KT sediments and in Greenland. Of course, it is possible that the nanodiamonds in Greenland formed through some as yet undiscovered natural process other than cosmic impact. However, that seems unlikely, since intense diamond research spanning more than a century indicates that the formation of nanodiamonds, and Lonsdaleite in particular, requires extraordinary temperature, pressure, and redox conditions that rule out natural processes that occur either on or below the surface of the Earth. Thus, since the YDB is the only other known continent-wide diamond layer in the entire tested geological record, other than that at the KT boundary, the most consistent hypothesis is that nanodiamonds in the YDB formed during a major cosmic impact event. Since Lonsdaleite is only known to form during high-temperature, high-pressure cosmic events, its presence currently can be explained in only two ways. Either the Lonsdaleite arrived already formed within meteoritic material, or crystallized during a hypervelocity impact with the Earth's surface. The rounded morphology, range of allotropes, and very high abundance of nanodiamonds in the nanodiamond peak layer appears to exclude the first possibility, arrival inside meteoritic material. Regarding a possible impact event, the Greenland nanodiamonds are identical to those found in the KT impact layers. So the presence of rounded nanodiamonds in Lonsdaleite in Greenland ice suggests that a large cosmic impact occurred, and further investigations are necessary to determine the nature and scope of this event. In summary, since continent-wide layers containing nanodiamonds are only known to exist at the KT boundary and the YDB, then the existence of this layer in Greenland ice appears consistent with the occurrence of a major impact event that correlates with the nanodiamond-rich YDB in North America at 12.9 thousand years ago. So that was a lot of interesting developments in the year 2010. And there's more that we'll go through in the next episode as we carry this up to the most recent evidence and research. I had somebody, there was one comment on the one of the last postings we did, and the Younger Dryas has been disproved. It was something else, and you're just looking, you're not keeping up with the latest science. Of course, he didn't cite anything at all. No papers, no work, nothing, no references. Nothing. Well, let's see. We talked about two papers that are just published right now as we speak. The finding in Louisiana and the finding in Siberia near the Altai Mountains. Well, those are all right now, like within the last 2 months. So I don't think it's me or us who's not keeping up with the latest science. Anyways, I think that's probably a good place to take a break for now, don't you?
I think so. We'll come back and we'll sally forth.
We'll sally forth. We'll move on ahead. I see up there 2011, and then there's some really good evidence coming up. And I want to look at some of the critics as well, because this is how science is supposed to work, where somebody proposes a new idea, an outrageous hypothesis, and you're supposed to try to take it apart. And if it comes through unscathed, it's worthy of inclusion in the pantheon of at least hypotheses that are worthy of testing. So what I do want to show, though, is that how some of the criticisms have been, in my mind, very biased. and working from preconceived assumptions. And I think that's going to be important too, because I think we'll see there that there's legitimate controversy and debate that goes on in science. And then when you begin to see somebody who's resorting to ad hominem attacks, appeals to authority,
it's because they've lost.
Yeah,
it's because they're at a loss in the moment or in total. They have lost, so they resort to that.
Yeah. The problem is that's fine, except that when scientific debate filters down into popular media is oftentimes going to be the worst when it comes to appeals to authority. And you oftentimes will see, I'll show you like the media itself saying, well, the experts have weighed in and disproven the impact hypothesis. And then you look at the credentials of the experts, and they're no more expertise than the people who are promoting, right? So somebody is making this decision, well, these are the experts, and these guys over here are the crackpots proposing this idea. And you're going to see, I mean, we're going to get in and we're going to look at some of what the critics, although, and again, there are some valuable critiques because there are things, this is not a cut and dried situation here. There are things that just don't quite add up, and we'll talk about those things. So on that note, I guess I'm ready to call it a day.
We'll see you next time.
Yeah,
thank you, Randall.
We'll be recording another episode soon.
Yes, sir.
Probably within a few days. All right, John.
Night.
Good night.